The day before our first test in a lake, we took the boat out into a field with a view to testing the various radio controls that we've got. This is Dick testing that the rudder can be controlled by the radio control, and then is me trying to make the LoRa telemetry work, and we discovered that Dick's Mavic drone, which we were using as a kind of video monitor, interfered with the LoRa telemetry. So as soon as the Mavic was turned on, the telemetry stopped. Anyway, in the end we managed to test that the radio control could control the rudder up to 250 meters away, and also the camera on the stern of the vessel was also transmitting video over a 250 meter distance, so we thought that's okay.
A little red dot when you press
Yes, it's working. Okay, so here we have extended Team Joker with Samuel Fielder, Dick, me, acting as cameraman this time, and the boat. So, you want to say anything, Peter?
No, because I've already done a little thing on that.
Right, okie dokie.
We've got our little Woodstock here.
Oh, yes.
He's got a rather wobbly head.
Right,
I'm going to carry this thing if I can.
No, I've got to give you a hand with it, have I?
Not yet.
No. Just shout instructions.
Did you bring your life jacket?
This is apparently where the base is going to be.
Oh, have you switched it? No, I haven't switched anything on yet.
Right, okay.
So, if you can switch on your bit,
Right,
Dick.
okay. I'll just steady that in these.
And did you bring the green screwdriver?
No.
I gave it to you.
No, you gave me those bits there. You can give
Right.
When I turn this on, the rudder should go left and right as yours does,
Right.
as Snoopy does,
Yeah.
and then come back to centre.
Right, okay.
But I'm going to wait till Dick has
Right.
got his stuff going.
What I've done is I've just switched on the. This is the stuff I pulled out of a model aircraft that has a camera in it, and I put the camera in there.
Right.
So that's that and that. This will come on when that goes on, doesn't it? So,
It will.
Yeah. So
That's the next thing we've got to test.
yeah. So that's all now up and running. Okay.
Right. Okay, so I'm going
Steady
to turn the main power on
Yeah.
now.
Okay.
Okay.
Yeah.
I'm going to put this lid on and do it up properly, and then Dick's going to test the rudder control servo.
I suppose if I fall in,
Can you do
I should keep the camera above water.
Yeah, just above your head. Never mind about where your head is,
Exactly.
as long as your arm is above.
We'll do both of them up as tight as they.
Right. This is the remote camera,
Right. Is that working?
and that's the radio control for the boat.
Okay. So we can put it in the water
So
now.
different things being
Somehow.
used for
Yep.
different things. Right.
What I
Okay.
haven't got is.
You want to get the LoRa plugged in, and
I'll bugger about that later.
right, okay.
And do one thing at a time.
Right.
Robin,
Did-
can you?
Yeah.
Can I take over?
Yeah. Sure. You take over the camera. It's rolling.
Yeah, okay.
Yeah.
I got it. So if you take the bows, and if you kneel down,
You can't do the mast. Can you do it? Can you
Yeah,
do, that,
yeah.
do it like that?
just mind the
Okay.
duck poo everywhere.
Yeah. I can see that.
Well done. It'd be funny if it just went straight down to the bottom, wouldn't it?
Don't jest.
I'm going to push it off.
Okay. I've got no control over it. Right, back to you with the camera.
Yeah.
How do I switch the... it's not working with the...
Up is you were controlling it before, right?
Yeah, but now I can see the rudder's not moving. Oh, yeah.
Ah, it's Roy coming. Just make sure you know these people, by the way. It's very important for on video. That is Samuel Fielder. I know down there, right? Right. In case you don't recognise him. Amazing. Just when you want the wind to blow, it stops.
Peter, what I'm finding is that it loses its contact with the radio control.
Well, we had 250 metres of contact, didn't we?
So
this is
I've
Peter's
now got
telemetry.
control with the radio, but
Yeah.
well,
Just running aground.
It won't go to the left at all. Water, do you think? Or maybe we've got water in the boat. Do you think we've got water?
so,
Right. Oh, Samuel has diagnosed the problem, which is
That's full right, that's centre, and that's full left.
right. Doesn't like that. So it
But-
slipped on the rudder linkage somewhere.
But
you tightened it up yesterday.
I know. I did tighten it up, and it was working this morning as we just filmed it. But how can it, just because it goes into water, have suddenly done that?
Yeah. Well, it'll be something simple and mechanical.
Unlike Snoopy, we'd have to undo 22 bolts to look at that.
Huh.
But it took one look at a drop of water and completely went haywire.
Right.
When it worked perfectly in a field.
Now, of course, because the thing is very well engineered for eventually going to sea, it just so happens it's going to be a load of work now to get at what the problem is, because there's lots of bolts to remove and
it's
things.
brazed on. It's brazed on, Roy.
Right, having diagnosed the problem, they're now going to do another test.
Just make sure the back of your hand doesn't stop it moving. Don't fall over. It's sitting in the mud, so
Yeah.
that's better.
Okay, so what's the change now?
We haven't changed anything. We're just
Fiddled until it worked.
doing very gentle and small rudder movements. And
Right.
if you do a rapid rudder movement, then that's when it loses itself, because the boat won't turn fast enough.
So the difference is you're doing small rudder movements, so you're not overstraining the...
Yes.
Uh,
Not provoking it into losing its position.
Alright, so it's conventional radio control there. Hey, looks like he's going to try and go around the buoy.
That was the plan.
And of course this is very light conditions, light wind conditions.
Luckily.
Well, yes, because we can see what's happening, can't we? I have some debate here, because the boat is going out a long way away. There's some debate whether one should go for a rescue downwind while we have the opportunity. Actually, the wind's coming up nice. We've got thermals, haven't we?
Further up. And a lot further up.
Right, okay.
We could go for a more adventurous mission to explore the island. There's a jetty inside the island.
Well, that would be nice.
It's all right. We've got Dick's camera on board.
It's not working.
Oh,
It's run out of battery.
that location over there, which it reached under autopilot control, was its first waypoint.
the way line is more or less shaves the island on the southern side.
Ah, that's dodgy.
And when it gets to there, it should then go back towards that black dog.
Right.
It's homing in on the Labrador.
Yeah, don't let the Labrador move.
Where's the Labrador? Oh, this one. So, is it approaching its next waypoint now?
No, the next waypoint is over there by this route.
Right over there?
Yeah.
So it's got to go past the island. That's going to be tough.
It's supposed to be going.
God, talk about living dangerously.
Yes, the autopilot sets the waypoint and the direction of steer from GPS and where it is.
Right.
Then the
compass
helmsman
is
works
on
on
the
the compass,
rudder.
entirely
Yeah.
on the compass.
Yeah.
So,
So we don't sure we're actually putting it on the record before it happens. So he's reached his first waypoint from base here,
And the helmsman is the micro mic, and the other thing.
and then
No,
he's
they're-
aiming
they're
for a
both- they're
second
both-
waypoint over
both
there.
those are in the
Different
micro mic.
subroutines in the
There is
And
no
the
Arduino
third
in the
waypoint
rudder
is where the
settle box.
doggy
It
is.
just controls the stepper motor and the optical
right.
positions, angular position sensors.
Well, that's all the video we've got of the actual test on the lake. I think Robin had a bit of finger trouble, and the last few shots that he took did not get onto the camera. What I'm going to do now is to replay the whole trip from the SD card that the autopilot records its log onto. Right, well, I'm replaying this log at 3 times real speed. You can see on the Google map there's a starting point on the little jetty we were on, and then there's a waypoint P1, which is where we're supposed to be going first, and then it's supposed to go back to P2, southwest to P2, and then east-southeast to the waypoint marked E, which for end. During this point, at this time, the boat is mainly being controlled by Dick using the radio control, and you can tell that by looking at the pink helmsman box, because the PWM signal on the right is significantly different from the steering instruction from the helmsman. So the radio control is overriding the helmsman. In this part, I think Dick is trying to turn the boat into the wind, and he eventually succeeds in doing so, and then he turns it back again, and in due course Dick realizes that the boat seems to be steering better by the autopilot than when he's controlling it by the radio, so he switches the radio off eventually and lets the autopilot take it to waypoint P1 at the top of the map there. I think at this point it's still under radio control, but maybe now it's under autopilot. The red circles around the waypoints are of 20 meters diameter, and when it actually gets within the red circle, the autopilot considers that it has reached the waypoint, and it then switches to the next waypoint. So if you see in the salmon pink box, it says waypoint P1 at the moment, but when it gets into that P1 red circle, it will switch to waypoint P2. Which it's about to do now. There you go. Now if you look at the bottom of the yellow screen, you see we suddenly get recal coming up. That's a message from the Arduino in the rudder servo, which has recognized that it's got its knickers in a twist and has recalibrated the rudder. That's because we were turning through 180 degrees, going back now southwest to waypoint P2, and unfortunately the servo is not strong enough to hold the rudder at such a large angle. So we're now going solely under autopilot to control, and at this point the wind dropped to almost nothing, and it was the wind, which is coming from the northwest, was shielded by that horseshoe-shaped island. So we spent quite a long time not moving very fast, as you can see from the speed over ground in the blue box, which comes from GPS. But eventually it gets going again. The wind picks up, and it then speeds towards P2. And when it gets to P2, it's supposed to turn through 90 degrees to port to waypoint E. But you will notice that when it gets there, it doesn't in fact manage to turn through the full angle required. I'll explain that when we get there. Basically, if you consider this to be a PID control algorithm, proportional integral derivative, I've just got the proportional bit at the moment. The integral is 0 and the derivative is 0, and as a result, if you ask the boat to turn through a large angle, it doesn't necessarily complete the full movement. So when we get into the red circle for P2, it will turn to port, but not quite enough. Here we go. So you see it's got onto a heading of 150, 148, when it's supposed to be, according to the autopilot, on 113. It keeps the same rudder angle and therefore keeps the same heading. And we're now running downwind, and the jib was out one side and the mainsail was out the other side of the boat. But it does manage to correct itself, get slightly more to port, but not enough to arrive at E. But it does arrive almost at the Black Labrador, which is good. And at this point, it's going to, as soon as it gets in the red circle, it's going to say end of mission. There you go. That's the end of it. Well, that's the end of our first test of Roger's boat in the water. I'm pretty pleased with it actually, because if you looked at that GPS plot, it really followed the way lines pretty accurately. I'm pleased with the helmsman loop, which is given a course to steer by the autopilot and then works solely on the compass to control the rudder, and it seemed to keep it dead straight, even though I had put in a totally arbitrary rudder gain of 0.7, and there is no integral and derivative part to the PID controller at the moment, but I need to put that in. The problem we had with the rudder were foreseeable. I had hoped that the 27:1 reduction ratio in the gearbox of the rudder would be sufficient to hold the rudder in a fixed position without any power being applied to the stepper motor. So I've got no holding current on the stepper motor. But unfortunately, if you're turning the boat through too wide an angle, then the hydrodynamic forces on the rudder are sufficient to overpower the gearing and move the stepper motor, the gearing and the stepper motor without the electronics realizing that this has happened. I do have an option in the circuit to turn on a holding current, but the disadvantage of doing that is that it enormously increases the current consumption of the rudder servo. So I think basically I've got to abandon this stepper motor with reduction gear and go back to the idea we first thought of, which is using a worm gear, which cannot be forced against its will by forces acting on the rudder itself. So what we'll probably do is put a Savox servo in temporarily so that we can test other aspects of the thing and work on getting a reliable worm wheel driven servo for the future. Another pleasing thing was the fact that the LoRa telemetry actually worked even from waypoint P1, which was quite a way out across the lake, we were still getting data back onto the laptop PC that I had there. The main problem with the whole thing is that in a bright sunlight you can't really see the laptop PC anyway. But the whole log goes onto an SD card anyway, so that doesn't matter. Thanks also to Horseshoe Lake Activity Centre, who allowed us to use the lake during the day to run this test. And thanks for watching.